This item is deceptively simple and straightforward. We're asked to find the value of W for which the rotation at the middle of this two-span beam is 0. So we have two fixed ends, far left and right. We've got uniformly distributed load on the left span at 20 feet. We have a concentrated load at the mid-span of the right span, which is also 20 feet. Both of them have the same value of EI. So of course EI over L for both are the same, but the critical thing here is find the value for W which the rotation at the middle is 0. If that's the case, then that means both sides are the same thing as though they were fixed. And we can borrow from our understanding of moment distribution to understand what's going to really happen here. But what this ultimately really means is we just got to set the fixed end moments for these two to be the same. Now I got to double check here. Fixed end moment on the right side is going to be PL over 8, I believe. Yeah, I'm confident that's the case. It's PL over 8. Right? Why do I say this has to be the case? Because think about moment distribution. We lock all the joints down, we've figured out the relative stiffnesses, but the big thing is if the two moments are equal and opposite to each other, there's no unbalanced moment. I can then release the joint and nothing happens. So if it starts off at 0 rotation and we're in equilibrium and I let go, nothing's going to happen. So that will be the key here, that W then will be equal to 12 over 8 times PL over L squared, and so one of the L goes away and we have 3P over 2L is our answer. Right? Now in part B they say, well, discuss whether your answer to part A changes if the ratio of EI over L between the two spans is different than 1 to 1, and we're conditioned to think that, okay, relative stiffness is everything in terms of distribution of unbalanced moments. But wait a minute here, we don't have any unbalanced moment. So it doesn't really matter in this particular case, because the fixed end moments were coming from loads that were not dependent upon EI and L values other than, and here's maybe a key, this is pretty subtle in some ways. If the ratio of EI over L is the same, then it doesn't come into play. If all we do is change the EIs. Now if we change the L's, then this won't be quite so simple anymore. This will be PL1 over L2 squared. There'll still be the 3/2 factor. So it actually does matter a little bit about how we change the EI over L. So in one sense, no, it doesn't matter. We're not a function of EI, but we are a function of the span lengths. So the answer to part B really needs to be that, well, it depends on how you might approach this. So there's your answer to part A. Part B is, well, it depends on what we do in the setup of that. So that's kind of subtle. The major part is that the EI is not a primary element of the fixed end moments, but those span values are, which is kind of interesting.